Welcome back. Today's topic is design a non-deterministic push-down automata for the language L equals to WR such that W is belongs to A plus B whole closure. So first write down what is the W. It is a regular expression, all combinations of A's and B's including epsilon. So epsilon is the first possible string, then single A, single B, two A's, AB, then BA, then BB, and so on. Then what is the reverse of the string WR is? So epsilon only, A only, B only, then 2A's only, then it is BA, then it is AB, then it is double B, and so on. Now let me write what are the possible strings over this language is L equals to, for example, if I take an AB is the string, so reverse of the string is what? BA. Then if I take an BAA is the string, what is the reverse of the string? AB, and so on, this type of the strings. Okay, so I am asking you to construct the non-deterministic push-down automata. You know what is non-deterministic push-down automata? Out of all transitions, for at least one transition, there should be a more than one move. Then we can call that it is the non-deterministic push-down automata. Okay, see, before designing the non-deterministic push-down automata, first let me tell you the solution. So here I written the solution. The logic behind is, first read all input symbols, either A's or B's onto the stack. Then compare if top of the stack and next input symbol is same, do the pop operation. First analyze the logic. Initial state is Q0. Let's assume this is the string and it is the WR. So Q0, input symbol is A, read A, add on to the stack. Then next input symbol is A, read A and add on to the stack is one possibility. And another possibility is change from Q0 to Q1 state, top of the stack is A and next input symbol A, do the pop operation. This is two possibilities we are writing. Okay, then next input symbol is B, read B, add on to the stack. Next input symbol is B and top of the stack is B, so you can add B onto the stack is one possibility, or else you can do the pop operation. Then next input symbol is A, you can add A onto the stack. Then next input symbol is A, you can add A onto the stack, or else you do the pop operation. So this is all possibilities. Finally, if all input symbols are exhausted, so you try to move from Q1 state to QF so that we can indicate that string is accepted by final state. Later you make the stack is empty so that we can indicate the string is accepted by empty stack. So first write the transitions. Transition of Q0, first input symbol A, top of the stack is Z0. So whatever the first input symbol, either A or B, add symbol onto the stack. So Q0, A, Z0. Let's assume if the first input symbol is B, top of the stack is Z0, same thing, add B onto the stack. Then let's assume that first input symbol is A and next input symbol is B. So transition of Q0, first input symbol is A and next input symbol is B, so same thing, add B onto the stack. It is Q0 BA. So how the stack looks like is, it is Z0, so already top of the stack is A, add B onto the stack. Okay, then let's assume that first input symbol is B and next input symbol is A. So transition of Q0 A comma B equals to Q0 A B. So this is how stacks looks like is. So it is Z0, so already top of the stack is B, now we are adding A onto the stack. Okay, so now transition of Q0, first input symbol is A and next input symbol is also A, let's assume. Okay, so I written the two cases for this. If first input symbol is A and next input symbol is A, I mean next input symbol and top of the stack is same, is you can add A onto the stack is one move, and another move is we can pop the symbol from the top of the stack. So for both cases we are writing that is equals to Q0 A. So this is what meaning I am adding element A onto the stack. What is other option for this transition is move to the state next state Q1, do the pop operation. This is what non-deterministic push down automata. For the same transitions we have more than one move. Then next one, transition of Q0, input symbol is B, top of the stack is B. So I told you, so if input symbol is B, top of the stack is B, add B onto the stack is one option, otherwise do the pop operation. So that is equals to Q0 B, comma, and another option is Q1 comma epsilon. These two transitions makes that this design is the non-deterministic push down automata. See, for single transitions we have more than one view. For the single transition we have more than one view. Okay. See, second view we represented here. For 2 A's doing one pop operation. For 2 B's doing the one pop operation. For 2 A's doing the one pop operation. Okay. Let's assume that we are in state Q1. Top of the stack is A. And next input symbol is A. So we are going to do the pop operation remaining on the same state Q1 comma epsilon. Similarly, transition of Q1, if top of the stack is B, next input symbol is B. So doing the pop operation, that is equals to Q1 comma epsilon. Okay. So after doing pop operation, let's assume that stack contains only Z0. Okay. So no input symbols to process because it is the epsilon. So transition of Q1 comma epsilon comma Z0 equals to move to the final state QF comma Z0. So this is what called acceptance by final state. If I want to write the same design suitable to the acceptance by empty stack, so how we written it is transition of Q1 comma epsilon comma Z0 equals to remains on the same state by removing Z0 from the stack. So Q1 comma epsilon, this is what called acceptance by empty stack. If W equals to epsilon, what is language contains? Epsilon only. So for that case we have to write transition Q0, input symbol is epsilon, top of the stack is Z0. So that is equals to, we can move directly to the final state QF comma Z0. Now draw the graphical notation. Initial state is Q0, starting state. We have one more state is Q1 and next state is QF. So Q0, it's a self state. If input symbol is A, top of the stack is Z0, add A onto the stack. The next one. If input symbol is B, top of the stack is Z0, add B onto the stack. The next one. If input symbol is B, top of the stack is A, add B onto the stack. If input symbol is A, top of the stack is B, add A onto the stack. Okay. Then, so how you can find out the ending of the string and starting of the reverse of the string is if the same if next input symbol is A and top of the stack is A means there we can identify maybe it is the reverse of the string. Okay. So next input symbol is A, top of the stack is A, add A onto the stack. Similarly, we have one more transition. So do the pop operation. So input symbol is A, top of the stack is A, do the pop operation. Then next, input symbol is B, top of the stack is B, add B onto the stack. So we have one more move for the same transition. Input symbol is B, top of the stack is B, do the pop operation. Then in Q1 state, if you find out the same input symbol and same top of the stack, do the pop operation. So A comma A is epsilon, then B comma B is epsilon. Then so after input is empty, move to the final state epsilon comma Z0, not doing any operation on the stack. Then so this is acceptance by final state. How I can add acceptance by empty stack is on Q1 state, it's a self state, input symbol is epsilon, top of the stack is Z0, remove element from the stack epsilon. This is what case if W equals to epsilon. So we have to add this also. So Q0, so Q0 epsilon comma Z0, move to the final state Z0. Now check for the string acceptance. Let's take the string AB BA. Now write the instantaneous descriptions, IDs. You know, by using ID at any time we can analyze the configuration of the push down automata, whether it is deterministic push down automata or non-deterministic push down automata. So initial state is Q0, input string is A, B, B, A. Top of the stack is Z0. This is the first ID. Okay, so Q0 input symbol is A, top of the stack is Z0. So which one is suitable? This is suitable. Okay, so add A onto the stack. So next ID is Q0 B, B, A, Z0. Okay, so after processing this input symbol, so next present state is Q0, input symbol is B, top of the stack is A. Input symbol is B, top of the stack is A. So add B onto the stack. So next ID is Q0 B A comma B A Z0. Right. So present state is Q0, input symbol is B, top of the stack is B. This is the case, it can suitable. So we have two moves. I mean, we have two options to process this string. So let's write the two options. So one option is this one. State is Q0, next input symbol is A, and add B onto the stack. So it is B, B, A, Z0. Then another option is move to the state Q1. Yeah, remove the top of the element from the stack. A comma A Z0. If you move on this, it's not possible to accept this string. Then process this one. So on Q1, present state is Q1, input symbol is A, top of the stack is A. So Q1 A. So you can use this. Do the pop operation, remains on the same state Q1 comma epsilon comma Z0. If you remove A from this, Z0 only. So Q1 epsilon Z0, move to the final state. So it is QF comma Z0. So what this is, acceptance by final state. So this is what meaning of the non-deterministic push down automata. If you accept this string, there should be a more than one path of derivation to this string. So this path is not correct path, this path is correct path.